Hi, my name is John Higgins and welcome to my channel. This is the next video in the series of assembling my virtual pipe organ, and in particular my MIDI pedal board, so converting the original pedal board to be MIDI to connect in with the virtual sample sets. So we're at a very exciting stage now. So as you can see, I've soldered all of the reed switches. So we have ribbon cable on this side of the switches, which is where there'll be plus 5 volts DC to activate, and then we have a common earth, which you can see I've jumper leaded all of these short wires together, and that all goes back to the common earth. So what we have here is the MIDI converter. I'm not precisely sure on what the exact terminology is, but it's basically the MIDI converter or MIDI indexer. So we have here the what are called Molex fittings. So I'll just pull this off so you can see. So this is the Molex fitting. It's quite common, and I had to crimp all of these wires onto, there's some little brass or copper fittings inside there, which you crimp and click them all together, and then you can see the circuit board here has all of these very fine pins, and not easy to see, and you have to be very gentle. Plug this in. There it goes. And so we have here channels 1 to 32, which corresponds to the 32 note pedal board. Then you'll see these two other additional wires here, and on the circuit board you can see it says ground. So this is the line that that connects back into the common earth or ground. So now we're at the very exciting stage of testing to see if this works. So I have here the DC power supply. So in Australia it converts from 240 volts 50 cycles AC to plus 12 volts DC output, and I believe this particular power supply is I believe it's a 2 amp or 24 watt. So you don't need a lot of power to power these electronics. So what you'll note here is we have a LED for power, and then there's a red LED here which indicates when the MIDI signal has been received. So we'll plug the power in, and you can see, sorry, the light is a bit bright, but you can see that LED is lit up, so that's fantastic. That means we're getting power. Now what I have here is the series of rare earth magnets. I'll take them out of the packet just so you can see them, and these little magnets will be attached to the back of each pedal. So there's obviously 32 of these. They're very tiny, as you can see if I compare it to my thumbnail. It gives you an indication of the size. They're very small but quite powerful. And as I say, each one of these will be attached to a pedal. And when this rack that I've built, this whole wooden assembly here is screwed and glued into position, these magnets will be positioned right next to the reed switches. So what we're going to do now is simulate this working. So let's pick this particular reed switch here, and if you watch very carefully, I'll bring this magnet and swipe over the top of it, and watch the LED. And you see the red LED here is flashing, which is absolutely fantastic. So the manufacturer recommends that these magnets are installed approximately 1/4 of an inch or 6 millimeters away, and so that would be about this height here. And you can see when I sweep past, I'm getting very clear and distinct switching on and off. And that's how the MIDI works. It sends a signal for both on and off. And you can actually see if I lift this magnet further above the switch now, there's nothing. And now there's the signal. So it's actually working nearly 1/2 an inch or 10 millimeters away, but obviously we want it closer than that to give a more precise signal. So let's experiment with a couple of others just to make sure, which is a good idea while I've got everything out. So I'll move this here where you can still see the LED. So that one's working well. If I'm very quiet, you might actually hear the clicking of these reed switches. It's very, very faint. So as you can see, all of these reed switches are functioning very nicely. So that's some sort of a miracle for mechanical engineer doing electrical soldering, but it actually appears everything is working 100%. So, and I'll just check down the lower end of the pedal board now, which is out of the view of the camera, but you can see the LED is flashing quite nicely as I hover these magnets over. So this is, I'm so pleased, because this means that all the wiring is sound, all the switches are working, and this circuit board is working well. So that's the end of this video. I just thought I'd give you a quick demonstration, and I'm thrilled that all of that is working very, very well. So that's a wonderful step. So what will be next is, you can see on this circuit board we have the MIDI in and MIDI out ports, which you can see here. And in the kit there's the adapter plugs from these to go to the USB, which will plug into the computer to do the pedal board. And the other part, which is going to require a little bit of work on my behalf, is to set up the swell pedal to regulate the volume. So there's a number of pins here. So there's a ground, power, and then there's 4 pins which will be connected to a variable resistor, or a sliding potentiometer is the correct terminology. And you can see those 6 pins there. So there's a pin for power, a pin for ground, and then there's a pin for the maximum position and minimum position, and then the sliding potentiometer giving the variable range in between. And that will then have to be fed back. The sliding potentiometer then has to be connected to the swell shoe pedal, and then that signal will feed back into this circuit board, which goes back into the laptop, and that will control the swell division. So thank you so much for watching this video. I hope I haven't rambled on too much, but this is a very exciting step now to have all of this working, and I'm very excited that the next video should be able to demonstrate the pedal board working. So thank you, and we'll catch you next time. Take care. Bye.